Good morning, sixth grade. Hopefully, everybody had a great night last night. Today, we're going to start a new lesson. It's the last lesson of Chapter 11. Chapter 11, Lesson 8, Similarities and Transformations. Okay, let's look at the notes here. So, you're in your Google Classroom. Go here to Classwork. Scroll down here to Chapter 11. Click on that. And down here is your Chapter 11, Lesson 8 completed notes. So, let's take a look at these here. We have similarities and transformations, last lesson on chapter 11 here. So now yesterday we looked at dilations. Dilations, if you remember, we talked about, hey, the shape is still the same, the size is different. Okay, so all we've done, we either expanded it by doing it by a dilation that's greater than 1, or we reduced it down with a dilation that's less than 1 but greater than 0. So today we're going to sort of take that information that we used and talk about similar triangles, similar different shapes that we're dealing with here with similarities. Okay, similarities are basically going to mean that, hey, the objects are still in proportion. Their sizes are not the same, okay, but they are still in the same shape, same proportion. So, something here that you're going to need to understand first before we begin. Now, remember, we've talked about several different things here. We've talked about an equal sign. Everybody knows what an equal sign. Equal means, hey, this side's the same as this side here. In geometry, we talked about a congruency sign. It's our equals with a squiggle over top of it. This means that the objects are congruent. If we said this triangle here and this triangle here are congruent, which means they're exactly the same size, the exact same shape, nothing is different. The only thing, they may be twisted, turned, slid, or flipped, but that's okay. Their sizes are exactly the same. The third thing we're going to look at here is what's known as similar, okay? If they are similar. This here, if we remember, we just pull out the equal sign of the congruency, and we just have this little squiggle here, okay? This means that they are similar. Now, a couple of things I want to show you that are very important here. This says triangle ABC is similar to triangle DEF. Now, I think we've talked about this before. I want to show you a couple of things here. It says that point A is similar to point D, okay? Point B, right here, is similar to point E, okay? And finally, point C is similar to point F. Okay, we did points. Now, if we talked about our segments, we could say, hey, segment AB is similar to segment DE. We could also say, hey, segment BC is similar to segment EF. And then finally, we could say, hey, segment AC is similar to segment DF. You see how these match up. A goes with D, B goes with E, C goes with F. We know that those are all similar to one another. Okay, so let's see what it says here about identifying them. So it says, recall that a dilation changes the size of the figure by a scale factor. It's we talked about yesterday. Since the size of a figure is changed, the image and pre-image are not congruent, which means they're not equal to each other. The sizes are similar, but the images are not congruent, okay? Two figures are similar if the second can be obtained from the first by a sequence of transformations and dilations. Okay, remember our transformations. We may be dealing with a slide, we translate it. It may be dealing with a flip, okay, dealing with a reflection. Okay, so those are the different things that we're dealing with here. Okay, a rotation, going around a particular point. Okay, so that's what we mean. And then dilation means, hey, are we increasing it or are we making it smaller? So that's what we're looking at here. Okay, so let's see what we have here now. It says, determine if the figures are similar by using transformations. Okay, explain your reasoning. Okay, so if we take a look here, okay, we're going to say we're going triangle. Let's write this down here. Make sure you write this right here. Okay, let's say triangle. Okay, let's go E, D, F. Okay, and what we're going to see is how does that compare with triangle? Now, E is going to go with what? E looks like it's going to go with H. So we'll do an H here. Okay, D looks like it goes to G. So I'll put a G here because D is in the middle, so G has to be middle. And F looks like it goes to I. So F is at the end, so I'll do I at the end here. Okay, so right now it looks like we got D, E, D, F, and we're comparing it to H, G, I. Okay, so now what are we doing here? We are moving it from, we're going to say we're going from E, D, F over to H, G, I. So it looks like we are sliding it to the right. So this is a translation. Okay, since it's a translation, okay, we're moving it to the right, and it looks like it's getting bigger. Okay, so it's getting bigger. So we're going from a smaller to a bigger. So we're trying to figure out, hey, what's our scale factor going to be? If we're going from EDF to HGI. Well, first of all, we got to see, okay, are they similar? Which means we're going to look at the ratios. We got to look here at the ratio. So let's take HI. So let me just clear this here. We're going to take HI. We're going to go right here. This is known as the hypotenuse here, okay? And we're going to look to see, hey, how does it compare to EF? Okay, now remember, it's getting bigger. Since we're getting bigger, the larger number has to be on top, and I'll show you why in a second here. So HI is 10, and EF is 5. 10 over 5 is 2. So we're increasing it by a scale factor of 2. Okay, now here's why we don't do EF over HI. Because if I did EF over HI, I would get a scale factor of 1/2. Does that mean we're going smaller to bigger? No, that means we're going bigger to smaller. Okay, so we know this is increasing, and it's increasing by a dilation of a scale factor of 2. Now we need to check around to make sure everything else is the same. So let's hear. Now I wrote these numbers in here, and you may say, hey, how did I get these numbers here? Well, I counted. So from D to E, it's going to be 1, 2, 3, 4. So I know that's 4. From D to F, it's 1, 2, 3. Okay, so I know this is 4, this is 3. Go over here, do the same thing. G to H, 1, 2, 3, 4, 5, 6, 7, 8. We know that that's 8, and G to I, 1, 2, 3, 4, 5, 6. We know that's 6. Okay, so let's check these ratios to make sure they are still the same. Okay, so we have here HG. HG is 8. ED is 4. 8 over 4 is 2. Yes, that works. Let's go GI over DF. GI is 6 over 3, which is 2. So yes, that works. So now we're going to write a similarity statement. This is known as a similarity statement here. Now remember, order is going to be important. If I start with D, then I have to on the other side start with G. Then if I go to E, on the other side I must go to H. Then I go to F, then I must on the other side go to I. Now I can switch these around, that's fine. But if I start with F, on the other side I must have an I. Okay, so they must be in some type of order here. So triangle DEF is similar to triangle GHI. Very good. Okay, so let's see what we're doing here on this next one here. Let's scroll down here a little bit. So I've decided, hey, I'm going from this triangle to this triangle here. So smaller to bigger. So that means that my dilation or my scale factor must be greater than 1. Okay, so if we look here, it looks like we have a reflection, and then we translate it down, okay, and then we dilate it. Well, let's first see, are they similar or not? Okay, so let me take HK. It sort of looks like HK goes with EG. Okay, well, let's figure out what these measurements are. So HK, from H, I go 1, 2, 3, so it's this 3, to KJ, 1, 2, 3, 4. Okay, so we have 3 and 4. Over here, we go from E to G, so it's 1, 2, 3, 4. And from G to F, 1, 2, 3, 4, 5, 6. Okay, we have 6 here. So now let's go our larger over our smaller. So EG over HK. Well, let's see what we have here. 4 over 3. Okay, 4 over 3, 1 1/3. Okay, with that, or just keep it as 4 over 3. Okay, so now let's go right here. 6 over 4. If I reduce 6 over 4, that's 3 over 2, or 1 1/2. Are these ratios the same? Are these fractions here the same? No. No, they are not. Since they are not, these triangles are not similar at all. Okay, let's go down here to the next one. Okay, so if we look here, it looks like we have a rotation around point W. So we're rotating it up, and then we are dilating it. It looks like we're going smaller to bigger. So we got to know what side goes with what. It looks like here UV is going to go with ZW. Okay, that makes sense. UT is going to go with ZY. Okay, well, let's see if they are similar to each other. So let's start here with the ZY. So we see ZY. Now we know we're going smaller to larger, so the larger number has to be on top. We figure this is 3, this is 4. So it looks like it's going to be 4 over 3. Okay, 4 over 3, 1 1/3. Okay, now let's look here. Let's go with ZW. The ZW here is 7. And then we have UV, which is 5. So that's going to be 7 over 5. Guess what? That's not the same as 4 over 3. 7 over 5 and 4 over 3 are not the same at all. So these rectangles are not similar. Let's go over to example 4. Let's see what we have here. So it looks like we have some type of a rotation up here. Hey, but let's see. We're going to go from bigger right here. We're going to rotate it down into a smaller. So that means that the dilation or scale factor is going to be less than 1, but greater than 0. So let's see what we have here. It looks like we have KH is going to go with LM, and HI is going to go with MN. Okay, so remember, we're going bigger to smaller, so we're dealing with less than 1. So the smaller number here must go on top. So let's go here with the LM here. LM, which is 3, over HK, which is 6. Reduce that, and you get 1/2. Good to go. Let's try the next one. MN. MN right here, this side here is 2 over HI, which is 4. 2 over 4 is 1/2 also. Guess what, guys? These are similar. So we're going to write our similarity statement. This is rectangle KHIJ, because K goes with O, H goes with L, I goes with M, and J goes with N. Okay, everybody understand that? Now let's see. Did Mr. Spencer get that right? So H goes with O. We had H is going to tip down. And yes, we should be good there. Okay, K and O. Boom. Okay, yeah, we should be good to go there. It should all work out here. So is similar to rectangle OLMN. So there we go there. So you know what? I don't like that much. Because if I were to tip it down, I say, hey, let's take a look at this here. K. K they're saying goes with O. Okay. I can accept that. K goes with O. I would prefer K go to L. Let's make it an L. I like it L. K goes up because I want to tip this down. Okay, tip this down. So, and then I like H to go with M. I like H going with M. Good. I like H going with M. I like I'm saying I going with N. I like that. I going with N. Okay, N. And then I like the J. The J here goes with the, let me see, L is going to go with the O. I like that there. Okay, so let's change this here. I think this is still right here. We can probably, because it is a rectangle. Okay, but let's change it. So rectangle KHIJ is similar to rectangle LMNO. I like that better there. There we go there. So let's see what else we got here. Last page. Let's look down here. Use the scale factor. It says similar figures have the same shape, but may have different sizes. That's what we're dealing here with here. Okay. The size of two figures are related to a scale factor of dilation. That's what we talked about yesterday. You can find the dimensions of the image when given the scale factor and the dimensions of the original figure. Okay, so let's see what we have here. It says triangle ABC has sides that are 12 feet. So A is 12, B is 16, C is 20 feet long. Okay. It is related to triangle CDE by a scale factor of 0.5. Okay, so are we getting bigger or smaller? Yes, we are getting smaller because this is 0.5 is less than 1, but greater than 0. Find the lengths of the sides of triangle CDE. Now, so you understand, okay? Here we have, if you were to draw out your triangle, okay, and draw it up here. Here is triangle. Let's go A. We'll call this B. We'll call this C, okay? Now, we are saying, hey, what if I had triangle CDE, okay? CDE. So we've got triangle here, C, D, E. Okay. And we know that the side lengths will go A to B. A to B is 12. B to C is 16. And C to A is 20. Okay. And we're going to figure out what these sides are going to be. Now, we know that these sides are going to be at a scale factor of 0.5. So I'm going to take this 12 here, this AB side, and I'm going to do it for CD here. So if AB is 6, half is 12, half of 12 is 6. So I know that CD is 6 feet. This is how I got this information here. Now, if I know that B at BC is 16, I know that DE is half of 16, so this has to be 8. So there's how I got my 8 feet. And finally, I know that CA is 20, which makes EC half of that, which would make this 10. Okay, so I have 6 feet by 8 feet by 10 feet. There you go on this one here. Okay, let's look at this example here. It says triangle RST has sides that are 20 millimeters, 10 millimeters, and 25 millimeters. It is related to triangle FGH by a scale factor of 0.8. So there we go. It's going to be smaller. Okay. So find the lengths of the sides of the triangle FGH. Okay. We're just going to go through this very quickly. All we have to do is take each one of these sides, multiply it by 0.8, 20. So we have side RS is 20 times 0.8, which will be 16 millimeters. Side ST is 10 times 0.8. That is 8 millimeters. And then I have side RT, which is 25 times 0.8, which is 20 millimeters. So we know that my triangle FGH has new sides, 16 millimeters, 8 millimeters, and 20 millimeters. Very good. Okay, let's look at this Dalmatian. Dalmatian is hard to see here. But here we go. Real world application. It says Ken enlarges a photo shown by a scale factor of 2, which means it enlarges, it's going to get bigger on his web page. Then he enlarges the web page photo by a scale factor of 0.5 to print. What are the dimensions of the print? Are the enlarged photos similar to the original? Okay, so let's take a look here. We're going to do this piece by piece. We know here is our original here. This is the original that we have here. It's 2 inches by 3 inches, okay? That's our original here. Now it says on his web page, okay, actually on the can enlarge the photo shown. So first of all, he's going to enlarge it for his web page here. Double the size. So the original, which had a height of 2 and a length of 3. So the web page now, we double it. It's going to become a height of 4, a length of 6. Okay. Now he's going to print that from the web page. So now he's going to take it from the web page and he is going to enlarge it by 1.5 times, 1.5 times. So take this here, the 4, multiply it by 1.5, which will give you your 6 inches. Take your 6 inches, multiply it by 1.5, and that will give you your 9 inches. Now, we're going to see, are they similar? Well, if I do this, 2 over 3, 2 over 3 is equal to 2 over 3 if we reduce it. Let's take 4 over 6. If I reduce that, 4 over 6, what do I get? 2 over 3. Hey, if I take 6 over 9, I reduce it. Guess what I get? 2 over 3. So yes, they are similar. And the photo that he is going to print out is 6 inches by 9 inches. Okay, let's take a look at this last one here. It says, a bakery transfers a photo image onto a cookie sheet. The original photo, which is 8 inches by 10 inches, is reduced by a scale factor of 0.8, which means it's getting smaller. The baker decides the image is too large and reduces the image by a scale factor of 0.9. Okay, we're going down now even more. Okay, what are the dimensions of the final image that will appear on the cake? Is the reduced image similar to the original? Well, let's see. We have our original. It's an 8 by 10 inch picture. It says, okay, we're going to reduce it first by 0.8. So take 8 times 0.8, it gives you 6.4 inches. Take 10 times 0.8, it gives you 8 inches. Okay, so we reduced it the first time. Here are our measurements. We're saying, hey, it's still too big. We got to reduce that image down even more by 0.9. So we're going to take the 6.4, multiply that by 0.9, which will give us 5.76 inches. Take the 8 times 0.9, it will give us 7.2 inches. So we go from there. Now, we want to see, are they similar? Well, what you can do, if you need to, pull out your handy dandy calculator and punch in here. Go 8 divided by 10. What do you get? You get 0.8. Let's do 6.4 divided by 8. What do you get? 0.8. Let's do 5.76 divided by 7.2. Guess what you get? 0.8. Guess what? They are similar to each other. So yes, they are similar. So your new image at the final, reduced all the way down from the image, is going to be 5.76 inches by 7.2 inches. Okay, guys, hopefully you understood this information. If not, go back, rewatch the video. If you're still unsure, ask me some questions. Down here is your homework that you need to complete. Once you're done with that, you're good to go. And it looks like on Thursday, we are going to be having a catch-up day. We might also be having a meetup day. I think we need to meet up, see how everybody is doing, make sure everybody's doing okay. So I'll be sending you an invitation on that. Okay, guys, have a great day. Get to work. Take care. Bye-bye.